Myself Prayag Patel, working as assistant professor in IT ICT department of LG Institute of Engineering and Technology. In today's video lecture, I will discuss about the sorting algorithm. Many sorting algorithms are available. Now in today's video lecture, first we discuss different sorting algorithm and then consider the first method of sorting algorithm is bubble sort. Now first consider problem solving by algorithms. Many type of problem can be solved using the algorithms. Now consider the first problem as a sorting problem. What is the sorting? Sorting means arrange the given data in ascending or descending order is called the sorting. So sorting algorithm can be solved using algorithm. Second, consider the searching algorithm, also solved using the algorithm. So searching means find the desired element from the given list. Here use the searching method for binary search and consider as a sequential search like this. Now third problem is numerical problem. Some numerical problem also solved by using the algorithm. Next, consider the combinatorial problem, means consider the conditional or satisfy the some constraint and then solve the problem. So here consider the graph coloring problem as a combinatorial problem. Next problem consider as a graph problem. So here graph problem means BFS and DFS consider as a graph problem, and last consider as a string processing problem, means consider the many technique for string processing or string matching like finite automata string matching algorithm. So this different type of problem can be solved using the algorithm. Now consider the next point as a application of sorting. Here consider the first application of sorting as a phone bill. Consider phone bill means phone bill. In phone bill you see that the given data in some sorted order or date wise order or call wise order. Now consider the second as a bank statement or credit card bill. Transaction made are date wise sorted in this bill. Now consider the third as a filling form online, means in online filling form. Here consider the one as a select country. In select country drop box, consider the many countries. Here consider the all the countries are sorted in alphabetical order. This is considered as a application of sorting. Now consider the online shopping. In online shopping, consider the date wise or amount wise or price wise. You can arrange the data according to this in online shopping. Now consider the file or folder in your desktop. Consider this sorted by date wise or by name like this. So this is considered as an application of sorting. Now consider the type of sorting. Many sorting algorithms are available. Now consider the one by one. First sorting algorithm is a bubble sort. Second method consider as a selection sort. Then insertion sort, heap sort. Fifth consider as a cell sort. Then radix sort. Then bucket sort, counting sort, merge sort and quick sort. So total 10 different algorithm for sorting technique, means arrange the data in ascending or descending order. Using out of this all 10 methods, select any one method and arrange your data or sort your data in your requirement or according to your requirement. Now consider the before understanding the any sorting algorithm, first you understand what is the stability or stable sorting algorithm. So consider the for understanding of the stable sorting algorithm, consider the stable sorting algorithms maintain the relative order or records with equal keys. For example, consider the first example as a stable sorting algorithm. In stable sorting algorithm, here consider the 8 value occurs 2 times. So in this case, which 8 will be appear in first location and which 8 appear at next location in our sorted list. So here consider the first A array as a given array and array B as a sorted array. Now in given array consider the value as a 5, 8, 9, 8, 3. In this list consider 8 occurs 2 times. So if we arrange this list in ascending order, then first consider as a 3, then 5. Now consider the 8. 2 times 8 are available. So first 8 means first we put the first 8, then we put the second 8. So here consider the I 8 as a first as a M and J8 consider as a second at n location. So this is called this stable sorting algorithm. Means in given list, first 8 are available in our desired list as a first position. Now consider the second example as a unstable sorting. So in this consider first 8 at second position and next means second 8 at first position in our sorted list. So here consider m first then n. In first list consider m first then n. So this is called the stable and unstable sorting algorithm. Consider the another example for the stable sorting algorithm. Here consider the 4 page 7, 5, 2 and 5. So here 5 occurs two times. First 5 is red 5 and second 5 is black 5. So if we arrange this data in ascending order, then first consider the red 2, then red 5, then black 5, then black 7, because red 5 first appear before the black 5. Now not stable or unstable algorithm consider the reverse of the previous case, means first consider the black 5, then consider the red 5 is called the unstable sorting algorithm. Now some algorithms are stable sorting algorithm, for example bubble sort, insertion sort, merge sort and counting sort consider as a stable sorting algorithm. Now consider the in place sorting algorithm. Two things are important before understanding of all the algorithms. First is stability and in place sorting algorithm. Now what is the in place sorting algorithm? A sort algorithm in which the sorted items occupy the same storage as the original ones, means no extra storage is required, is called the in place sorting algorithm. For example, consider the one array. In this array total 5 elements 1 2 3 4 5. Now after sorting this element in descending order, you require only 5 location, no any extra location are required, is called the in place sorting algorithm. For example, descending order like 5 4 3 2 1. Now consider the another example of the in place sorting algorithm. First step, consider the value 1 2 3 4 5 6 7. If you want to arrange this data into the descending order, then first swap 1 and 7. So consider the second step as a swapping after the 1 and 7. Now swap the 2 and 6 in second step. Now after that consider the step 3, swap 3 and 5. After that resultant array consider as a 7 6 5 4 3 2 1. So in this case no any extra storage are required. That's why we can say that this is a in place sorting algorithm. Now consider the example of in place sorting algorithm. Some algorithms are in place. So consider the bubble sort, selection sort, insertion sort, heap sort, cell sort and quick sort consider as a in place sorting algorithm. Now after that consider the first method of the sorting algorithms, and first method is bubble sort algorithm. Now consider the method of the bubble sort. It is a simple sorting algorithm that work by comparing each pair of adjacent items and swap them if they are in the wrong order. Means if compare first and second location, then second and third location, then third and fourth location, and if the particular location are not matched or not satisfy the condition, means consider as a wrong order. If the given data in wrong order, then swap this element. The pass through the list is repeated until the no swap are needed, which indicates that the list is sorted. Next point consider as it only use the comparisons to operate on elements. It is a comparison sort. So we can say that the comparison sort also. Although the algorithms is simple, it is too slow for practical use. Now this algorithm considered as a stable sorting algorithm, and bubble sort algorithm also considered as a in place sorting algorithm. So bubble sort is a stable and in place sorting algorithm. Now understand the bubble sort using the one example. Here consider the given array as a 45, 34, 56, 23 and 12, and sort the following array in ascending order using the bubble sort is our example. Now consider the first step or first condition. Here consider condition as a if a of j is greater than a of j plus 1, then swap the a of j with a of j plus 1. Means we can say that both the elements are not in proper sequence or proper order. Then swap these two elements. A of j means consider as the first value, a of j plus 1 means consider as a next value. So compare these two elements and swap according to this. Now consider the pass number 1. Here given data like 45, 34, 56, 23 and 12. Now compare the a of j with a of j plus 1. So here start the process from the first element. So 45 consider as a of j and 34 consider as a of j plus 1. So initially we compare 45 with 34. Now check the condition a of j means 45 is greater than a of j plus 1 means 34. So 45 is greater than 34. Yes, then swap the a of j with a of j plus 1. So swap these two elements. Here consider the 45 and 34 element are swapped. So first we put the 34, then we put the 45 after swapping of these two elements. Now in next step we consider the element as a first step. We have a element as a sequence 34, 45, 56, 23 and 12. We already compared the first and second location. Now we compare the second and third location. So here consider the next two location as a 45 and 56. Now 45 is greater than 56, condition is not satisfied. So no need to swap these two elements and move to the next element. So here consider the next two location as a 56 and 23. So compare the 56 with 23. 56 as a of j and 23 as a of j plus 1. So a of j is greater than a of j plus 1. Yes. Then swap the a of j with a of j plus 1. So swap these two elements 56 and 23. After swapping, we put the 23 at third location and 56 at fourth location. After that, consider the next step as a comparing next two elements. Means compare 56 with 12. So here compare these two last two elements 56 and 12. Now consider the condition 56 as a of j and 12 as a of j plus 1. So a of j is greater than a of j plus 1. Condition is satisfied. So we swap these two elements, means swap 56 and 12. And after swapping, consider the 12 at upper position and 56 at last position. So after swapping of this process, we reach at the last element. After completion of the pass 1, we will get the one element as a sorted element at the last position. So here we can say that 56 occupy his proper place. So in next step or in next case, we did not compare the 56 with any other element. That's why we can say the 56 occupy his proper place. Now consider the next step, step number 2 or pass number 2. In pass number 2, we already have a list according to our first pass. After finishing of the first pass, resultant array consider as an input for the pass number 2. So here in pass number 2, 56 consider as a already sorted element. Now same process will be repeated. So first compare the first element and second element. So here consider the 34 compare with 45. But this order is proper, so no need to swap these two elements. Now consider the next two location as a 45 and 23. Compare these two elements. 45 is greater than 23. Yes. Then swap these two elements and consider the resultant array as a first 23, then 45. After that, consider the next two location as a 45 and 12. So compare these two locations 45 and 12. Here consider 45 is greater than 12. So swap these two elements. Consider the swapping process, and after swapping we can consider array as a 34, 23, 12, 45 and 56. So here consider last two elements 45 and 56 consider as a sorted element. So in next pass did not compare these two elements. Now consider the next pass, pass number 3. In pass number 3, resultant array as a 34, 23, 12, 45 and 56. So here only first three elements are not sorted. So process for these three elements. Now compare first element with the second, means 34 compare with 23. 34 is greater than 23. Yes, then swap these two elements and consider 23 at first, then 34. Now compare next two elements as a 34 and 12. Now check these two elements 34 and 12. Here 34 is greater than 12, then swap these two elements. Here swapping process are done. After swapping, we consider 12 at the second position and 34 at the third position. After that, consider the next pass as a pass number 4 because already 3 elements are sorted. Now consider the given array as a 23, 12, 34, 45 and 56. Now compare first two elements 23 and 12. Here consider 23 is greater than 12. Yes, then we can swap these two elements. So swap these two elements and resultant array consider as a 12 at first position, then 23, then 34, then 45, then 56. So this array considered as a sorted array. In given array, we have a total 5 element. So you can perform the n-1 passes or perform the n-1 step. So here consider n as a 5. So we can perform the n-1 means 4 pass. Then consider pass 4 as your resultant array as a 12, 23, 34, 45 and 56. So here consider this formula for the execution of this algorithm. Now consider the algorithm for the bubble sort method. Now we already understand one example of the bubble sort. Here for understanding purpose we consider the same example and consider the situation of array as a 34, 45, 23, 12 and 56. Now n equal to 5 because total 5 elements are there. Now what is the value of I and what is the value of j? We can consider according to our example. Now consider the algorithm. First step as an algorithm bubble sort A. Here bubble sort as a name of the algorithm. A consider as an argument. Here input as a array A and output we require sorted array A. Now first consider the condition of our algorithm. If A of j is greater than A of j plus 1, then swap A of j with the A of j plus 1. We already performed this operation in our example. So here this swapping operation can be written as a like this: A of j data transfer into temp, then A of j plus 1 transfer into A of j, then temp transfer into A of j plus 1. This 3 step consider as a simply swapping operation of A of j with the A of j plus 1. After that consider the one for loop for that. So here consider the j equal to 0 to n minus 1 minus I do if A of j greater than A of j plus 1. So this loop perform the operation for the comparison of first element with the second element according to this. So here what is the value of j? If we consider the value of n equal to 5, then j equal to 0, 1, 2, 3 because here condition is j starting from 0 to n minus 1 minus I. Now initially consider the value of I equal to 1. That's why we can say that the n minus 1 minus 1. So n minus 2. So consider the 5 minus 2 as a 3. So j equal to 0, 1, 2, 3 for the value of I equal to 1. Now upper loop of the j consider as a loop for I. And I loop used for the number of passes. Here how many number of passes we can perform? Here consider the n equal to 5. So n minus 1 passes are required to sort the data. So here consider n equal to 5 and 1 to 5 consider as a here data. So we can consider here 4 passes are required to perform this operation. So for I equal to 1 to n minus 1 for this loop. So here consider this loop for the number of passes. So here consider I equal to 1 to n minus 1 in place of n in this case. So here consider total number of passes as a n minus 1 passes. Now how we can find the complexity? So here consider the complexity for the bubble sort. Here consider the inner loop j equal to 0 to n minus 1 minus I and following conditions will be executed for n time because outer loop is considered from I equal to 1 to n. So we can say that the n time for the outer loop. Now consider the inner loop for j equal to 0 to n minus 1 minus I. In this case, this step will be executed for n square time, because first outer loop for n time and inner loop for n time. So this loop consider as a n square time. So final complexity of the bubble sort is n square. Now we understand how we can find the complexity one by one step. So here consider the algorithm for the bubble sort for I equal to 1 to n minus 1 to j equal to 0 to n minus 1 minus I, and following condition a of j greater than a of j plus 1, and then swapping operation. Now for each and every step or each and every line we can consider the cost and time two factors. Now first cost factor means C1, C2, C3, C4 like consider as a cost. Time means how many time particular statement will be executed is considered as a cost. So here consider the first line as a I equal to 1 to n 2. Here consider C1 as a cost and n as a time, because here consider the loop as a I equal to 1 to n minus 1. So n minus 1 time this loop will be satisfied, but one time for the wrong condition. So n minus 1 plus 1 means consider as a n time this loop will be executed. Now for the second step, consider the cost as a C2, time equal to outer loop consider as a 1 to n minus 1. So here sigma I equal to 1 to n minus 1. Here how many times this statement will be executed? J from 0 to n minus 1 minus I, means consider as a n minus 1 minus I plus 1. And here according to this we consider the one time for the wrong condition. So final equation is sigma I equal to 1 to n minus 1 n plus 1 minus I. Now for the next statement, if condition a of j greater than a of j plus 1, cost equal to C3 and time equal to sigma I equal to 1 to n minus 1 n minus I, because in previous case consider the n minus I plus 1, but in this case consider the 1 less than time of the particular loop, because in previous case we consider the wrong condition, here we consider only satisfy equations. So here consider next step as a C4, cost for the swapping operation, and time for this step consider as a sigma I equal to 1 to n minus 1 n minus I. Now solve this equation according to our formula for find the complexity. So here consider the common formula for the find the complexity as a addition of each and every line cost and time. So first multiply cost and time and addition of each and every steps of cost and time. So T of n equal to C1 into n plus C2 sigma I equal to 1 to n minus 1 n plus 1 minus I, plus C3 into sigma I equal to 1 to n minus 1 n minus I, plus C4 into sigma I equal to 1 to n minus 1 n minus I. Solve this equation and find the complexity as a n square. Now how we can solve this equation for understanding of or find the complexity? We can consider some equation for easy understanding. Now first equation is sigma I equal to 1 to n1. Then we can say that the sequence is 1 plus 1 plus 1 up to 1 for n time. Now for second equation sigma I equal to 1 to n minus 1 1. We can consider 1 plus 1 plus 1 up to 1 n minus 1 time. So this is a n minus 1. Now in third equation I equal to 1 to n I. So here consider first value as a 1 plus 2 plus 3 up to n equal to n plus 1 divided by 2. And last equation is sigma I equal to 1 to n minus 1 I. 1 plus 2 plus 3 up to n minus I. Consider as a n minus 1 divided by 2. So here consider this equation and find the complexity according to this. Now consider the our previous equation as a T of n equal to C1 n plus C2 sigma I equal to 1 to n minus 1 n plus 1 minus I, plus C3 sigma I equal to 1 n minus 1 n minus I, plus C4 sigma I equal to 1 n minus 1 I n minus I. Now solve this equation according to our previous equations. So T of n equal to C1n plus C2. Here consider the n plus 1 as a one part and I as a second part. So we can divide this equation into two parts. Sigma I equal to 1 to n minus 1 n plus 1 minus sigma I equal to 1 to n minus 1 I. According to this we can consider C3 part as a C3, n as a first part and I as a second part. In C4 also n as a first part and I as a second part. After that we consider C1n plus C2. Here consider n plus 1 as a constant and inner part consider only one value. So we can say that C2 n plus 1 sigma I equal to 1 to n minus 1 1 minus sigma I equal to 1 to n minus 1 I. According to this, we can consider in C3 part as well as in C4 part. Now after that, consider the final value as a C1n plus C2n plus 1. Now sigma I equal to 1 to n minus 1 1. What is the result of this equation? Sigma I equal to 1 to n minus 1 1 means upper limit minus lower limit plus 1. According to this, we can consider as a n minus 1 minus C2 n minus 1 divided by 2, because here consider the equation as a I equal to 1 to n minus 1. If the n sigma I equal to 1 to n I, then we can consider n plus 1 divided by 2. According to this, we can solve this equation C2 n minus 1 divided by 2. According to this, consider C3 n minus 1 minus C3 n minus 1 divided by 2 plus C4 n minus 1 minus C4 n minus 1 divided by 2. Now solve this equation means consider the n square part, n part and constant part. So consider the final step as a n square. Then constant consider as a C2 minus C2 by 2 plus C3 minus C3 by 2 plus C4 minus C4 by 2 plus n C1 plus C2 by 2 minus C3 plus C3 by 2 minus C4 plus C4 by 2 plus minus C2. So we can say that this equation as a an square plus bn plus c, because all the constant value considered as a, b and c respectively. So here consider an square plus bn plus c. So what is the complexity out of this equation? Here consider the highest power of n, because a, b, c consider as a constant. So highest power of the n consider as a 2. So our complexity is big O n square. So here consider worst case and average case complexity of the bubble sort algorithm equal to n square. Now consider the best case of the bubble sort. How we can consider the best case of the bubble sort? Same algorithm are there. Here consider the initial one variable consider as a flag, and we set the initial flag value equal to 1. So you consider integer flag equal to 1. Now remaining all part of the algorithm are same. So here consider the first for loop, then second for loop, then if condition. In if condition, before the swapping we consider flag equal to 0, means if the condition a of j greater than a of j plus 1 is satisfied, then consider the flag value equal to 0. Otherwise consider the flag value equal to 1. Then after we swap the a of j with the a of j plus 1. Now after the first j for loop, we consider the condition if flag equal to 1, then consider the C out as a already sorted element and break the for loop. So here consider the example and understand how this algorithm will work. So in first pass, consider the given array as a 12, 23, 34, 45 and 59. Means we can say that this data as a sorted data. So best case of the bubble sort means given data is already sorted, then we can say that this is a best case of the bubble sort. So here consider this example, given data is already sorted, so this is considered as a best case of the bubble sort. Now in pass 1 we consider the value as a 12, 23, 34, 45 and 50. Now consider the value of I as a 1 and value of j initially as a 0 according to our loop. So here consider the value of I equal to 0, I equal to 1 and j equal to 0. So j equal to 0 means j a of 0 compare with the a of j plus 1. So a of 0 compare with the a of 1 means 12 and 23 will be compared. Now consider these two elements are already sorted. So this condition is checked, a of j is greater than a of j plus 1. Yes. Then this condition is not satisfied. So we can say that the next process or next value of the j. So consider j equal to 1. For j equal to 1, compare 23 with the 34. These all two elements are already sorted. So a of j greater than a of j plus 1 condition is not satisfied. Now consider the next value of j equal to 2. So compare 34 with the 45. A of j greater than a of j plus 1 condition is not satisfied. Now consider next value of j equal to 3. Means compare 45 with 59 and consider a of j greater than a of j plus 1 condition is not satisfied. So in all the case we can consider that given condition a of j greater than a of j plus 1 is not satisfied. So this condition never satisfied. That's why we can say that flag equal to already 1, no, anytime we can set the flag equal to 0 or no perform any swap operation. So we can say that next as a check the condition, if flag equal to 1, yes, we already set the flag equal to 1 at initial stage, so here flag equal to 1. Now break statement means we can print that already sorted data and break the particular for loop means we can perform I equal to 1. For the I equal to 1 we can perform the first pass, no any further pass will be executed for I equal to 2, 3, 4 like this. So consider the only one time this loop will be executed. So we can say that only one iteration take place from 0 to n minus 2, means consider as a only pass 1 will be executed. So we can say that best case time complexity of the bubble sort algorithm is theta of n, because only one time particular loop will be executed. Thank you for watching this video.